Today, who wants to come to the board and actually finish it? I'll throw a pin at the one that gets picked. Okay? Now remember, unlike replication, instead of A pairing with T, so adenine with thymine, adenine is now going to pair with uracil, right?
Yeah.
Okay?
This is going to be a lot of writing.
Alright, thank you. So, does everybody agree with this? Okay. So, again, tell me how the mRNA is coming out of the cytoplasm. Why? Alright. So, yesterday, as we were going over, the DNA is transcribed into mRNA, and the mRNA is what allows that one strand to come out of the nucleus into the cytoplasm for today's topic, which is translation. Alright, so translation, if we've already gone from DNA to DNA with replication, and then DNA to mRNA with transcription, what is translation going to do if the end product is going to be a protein? Turn it into a protein? Exactly. So the mRNA is going to be coded for a protein, right? Okay? So I have a short little video clip for y'all real quick that actually shows how this happens in the cell. That dark enough for y'all? Okay. So. Now you can use your notes on the same sheet that you were handed on replication.
It turns out that each triplet of bases on the messenger RNA, called a codon, corresponds to a particular amino acid. Now there has to be a chemical connection between each triplet codon and each amino acid. A special adapter molecule called transfer RNA makes that connection. One end of the adapter carries a particular triplet of bases called an anticodon. This matches up with a specific triplet codon on the messenger RNA. The other end of the transfer RNA is capable of binding to the unique amino acid corresponding to that anticodon. Since there are 20 amino acids, there must be at least 20 different transfer RNA adapters. So, for a protein chain to be assembled, each triplet codon on the message is read. The transfer RNA adapter with the relevant anticodon binds the messenger. The amino acids at the other end of the transfer RNA adapters become joined by a peptide bond. Once the transfer RNA molecule is no longer needed, it's released. The process repeats, elongating the peptide chain until a stop codon is reached.
Okay? translation, we're in the cytoplasm, and your tRNA, which is your transfer RNA, right? So that is going to be carrying the anticodon to the codon. So each of these triplets, as we've broken them up, is a codon. Okay? So now that you've transcribed it, this is going to be your anticodon. Okay? So does that make sense? Alright. Now the tRNA is going to be carrying the amino acid that corresponds with this anticodon, right? Okay? So now that's where the codon charts want to come into play. Got one right here for y'all. There we go. Okay? So, let me pull one up on the board for me to look at real quick. Alright. So, what is going to be the amino acid that corresponds with its anticodon?
Met.
Can anyone take a guess? Matt, how'd you get it?
AUG is right here.
Okay, besides that, how would you do it if it was like this one? Where would you start?
On the left side, and you go to the top, and then go to the right.
Exactly. So you're going to start on the left side. So you're going to start at the left side, called first position. So you're going to go down first position to an A, right? Then you're going to go over second position to the second one, which is a U. Then you're going to go back down again on the right-hand side to the third position, which would be a G. Right? And like you said, that matches up with Met. Okay? Now, what would AAU be?
ASN.
Okay? So what's the abbreviations for it? ASN? Okay? Now, someone else, what would GGG be? ACU?
THR.
Okay. Alright. GGA.
GLY.
UAG? Stop. So UAG is a stop codon? So what happened?
It stops.
Right. So all of this is no longer important because that tRNA strand has just reached the stop codon. So now what's going to happen is these have formed peptide bonds between them, right? That is now your new protein. So take me back through the process of replication, back through translation, and how it all ties together. So we know replication is going from DNA to DNA, right? So that's making more copies of it, okay? So now transcription, DNA to mRNA, how does that relate to replication?
That gives you the anticodon.
It gives you the anticodons, right? So the anticodons are what is going to be leaving out on the mRNA strand into the cytoplasm to make the protein, right? So protein is made in translation. So how is transcription related to translation? You just took the mRNA strand and you paired it up with the anticodons that were carrying your amino acids, right? So what did you just make? Protein. Right. So this is actually what is going to be happening going back into meiosis with interphase with DNA synthesis, where this is how it's saying your genes are going to code for the proteins, right? So genes make up the DNA, and the DNA codes for the protein. Okay, so is that tying it all together for you guys? Okay? So, any more questions on this before we move on? No? Go ahead and stop it.